Okay, so this is the first video for the final exam review. This is not where I'm going to work out all the answers, so I'm going to post this before it's due probably, and it's just some helpful hints on how to set some of them up, just in case you get stuck, because I know that I get a lot of questions in class and not everybody has a chance to come get all their questions answered. So our midpoint formula is on the formula chart. It's x2 plus x1 over 2. So it's like you basically average the x's. That gets you your x. Then to get the y, you just average your y's. And notice, I didn't actually do it on purpose, but I can pretend like I did. I switched the 2 and the 1. Doesn't matter. You just add them together, so it doesn't matter which one you put first. Like I think on my wall it says it one way and it might say it the other way on the formula chart. Maybe they're all the same. I don't know. Doesn't matter. Just add them together, divide by 2. So here we're talking -9 plus -1 all over 2 and -6 plus 8 all over 2. Okay, distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. It doesn't really matter which one you call 1 and which one you call 2, as long as you put the same one first. So let's do on this one. And if I type it into my calculator, I'm not going to type the radical because I want it in simplest radical form. Now if it came up as 9, you would know that radical 9 is 3. But the chances are, because these 3 are radicals, that it's going to be a radical. Okay, so -2 minus -5, which becomes plus, minus a negative is the same as plus, squared plus 8 minus 2 squared. And this one you do the same way. I'm not going to set that one up for you. Just don't forget when you're simplifying radicals, you have to break it down and take out its pairs. I will do an example for you like that, but I wouldn't write this down because I'm making it up. So if we had radical 20, that breaks down. You just have to think of 2 things that multiply to get 20. There's lots of options. You could do 2 and 10, 4 and 5. Don't do 20 and 1. That's dumb and pointless. Okay, so closer together is better, I guess. Circle the prime numbers, because that can't break down again, but this can break down to 2 and 2. And any pairs you have come outside, but when the pairs escape the radical, only one of them really makes it out. So whenever you bring out a pair, it just becomes 1 on the outside, and then leftovers go inside. So radical 20 is the same as 2 radical 5. And for those of you who aren't the greatest listeners, I made this up. It has nothing to do with your final exam review. But darn, I didn't want to erase all that. I just wanted you to know for these problems. Oh my heavens, I can't do that. Oh, this is the worst. Why did I even need to erase it? Okay. On this one, I'll just tell you when you're looking for the third side of the triangle, it can fall between 2 numbers. This one right here, the lower number you get by subtracting the other 2 sides you have. And this one you get by adding them. It's pretty easy. Area is pi r squared here, and you're given r. Because there aren't pi's in the answer, that means you type pi in your calculator. This is a trapezoid, so the formula is 1/2 base 1 plus base 2. These will always be the 2 that are parallel to each other on a trapezoid. And then that's going to be times the height, which will be the distance between the 2 bases. All right, we have a right triangle. We know 2 sides. We're looking for the third side. Sounds exactly like Pythagorean theorem, which is a squared plus b squared equals c squared. Remember, c is going to be the hypotenuse, which is the side across from a right angle. So we're talking 13 squared over here. 7 squared plus b squared. And you could do a squared plus 7 squared. It doesn't matter because you just add them together. So then you should hopefully be able to solve that. This is T pattern, which is the one that starts at the end of the hypotenuse and you go to the altitude. That's the letter, or the value you write down first. Then you go altitude, that's 12, and that equals the altitude again over the other part of the hypotenuse. Then you just cross multiply and solve. If you do T and L pattern right, these two should always be the same. And here we have an L pattern. That's one that starts where the altitude meets the hypotenuse and goes towards the leg you have. So we're talking 9 over 15. Then you do the same leg, 15, over the entire hypotenuse, which is x. And then you'll cross, multiply, and solve. Notice these are the same again. Okay, these are corresponding angles, so you're just going to set them equal to each other. Not corresponding, don't listen to me. Alternate interior, my bad. We're throwing that way back to October. I know what you're thinking. How can she expect us to remember this? That girl's crazy. Maybe a little bit. Okay, now these are pretty easy because you're just like setting up a proportion. So it's like, let's call this x. Not x, no, I don't want to call that x. Whatever this is, it's in the same section as the 4. So those go together. And then this is 3 and it goes with the question mark. Now, it should be pretty easy to get what this little dot is, because if this is 3 and the whole thing's 5, you just subtract it, and that's 2. So the 2 goes with the 4, the 3 goes with the what? And then you cross multiply and solve. We did this pretty recently. Circles, we've got our, they're not in degrees, so we're looking at segment lengths, not arcs and angles. The 2 lines are crossing on the outside of the circle, which is when you do outside part times whole thing. And that will equal the same thing, but for the other line. So let's start with just this line. Outside part is 9. Whole thing is going to be 9 plus 15, which is 24. Then on this one, let's highlight it in blue for fun. Outside part is 8, and I do have a lot of people who will tell me the whole thing is 8x, which means 8 times x. Remember, you just added these together to get this whole thing, so don't do something crazy like multiply them. You could also do x plus 8, doesn't matter. And when you solve that, you'll distribute that. Okay, this is, these both are 45, 45, 90 triangles, which remember, on a 45, 45, 90, the legs are the same, and the hypotenuse is multiplied by radical 2. So that should help you if you know that this has to be 5 radical 5. But, well, no, they're all the same here, so you couldn't eliminate any there. But what we're going to do here, since we have the hypotenuse, is you would be dividing by radical 3. And not 3, sorry, radical 2. And here you're multiplying by radical 2. And part of this is I wanted you to get used to using different radicals. So if I take 2 radical 6 and divide that by radical 2, hopefully you will remember, because I'm not going to tell you how to do it yet, but these two should be able to reduce because they're both inside the radical. You can reduce anything on the outside together and anything on the inside together. You just can't do like those. And here, when you have 5 radical 5 times radical 2, because these are both under the radical, you should just be able to multiply what's on the inside. And yes, I basically gave you the answer, but I'm not going to circle it for you. You actually have to process what I said. Okay, this is just Pythagorean theorem, and this is the hypotenuse. I know I skipped this one. I don't know why. Just I like to go out of order sometimes. That's how I do my math. I'm going to call that x squared and then equals 10.6 squared. Okay, this is a 30, 60, 90. And we're sitting on the hypotenuse. So we have to start by going to the short leg, which would be dividing by 2. Not radical 2, just the whole number 2. And then once you get that, you'll get there by multiplying by a radical 3. Sorry for anybody that I threw off by going out of order. Not really, I'm not that sorry. Okay, these are trig. And I think some of the biggest issues you guys are going to run into on the final is that it's so much information. I don't know if you'll know to do trig. But I mean, any right triangle, I would always try Pythagorean theorem first. And they'll probably all be close together like this. Did I do Pythagorean theorem? Okay, so I tried the Pythagorean theorem first. If that doesn't work, you know, definitely try T&L pattern. If that's not going to work, see if they're 45, 45, 90, or 30, 60, 90. It will tell you, don't just guess. And if none of that works, all else fails, you got trig. And you can do trig on these if you want, but it won't simplify the radical for you, and that'll be a little bit extra work. Okay, so on this one, we have the angle. So this is regular old-fashioned trig. So first we write down our acute angle. Then we got to decide what we're looking for and what we're given. So we're looking for this guy, that's our hypotenuse, and we're given this guy. So our options are, is this leg opposite the angle or adjacent, meaning right next to it? And since it's one of the sides of this angle, it's adjacent. Opposite side would not touch the angle at all, like the actual vertex. Okay, so ka, toa. A and H is cosine. And the cosine is adjacent on top, hypotenuse on bottom. Easiest way to solve that is to switch and divide. So x equals 13 divided by cosine of 54. I'm solving these too much for y'all. I should make you do more. Okay, this is more fun trig, inverse trig, because you don't know the angle, but that's actually easier. So we're given the hypotenuse, and this side is opposite, which is sine, and so it's opposite on top and hypotenuse on bottom. Be very careful about this. Like, I always write these correctly because I'm awesome, but I don't make sure you write them perfectly. But I do know in Algebra 2, if you don't have this equal sign here, they count off for that because it means something. You might have no clue what it means, but that teacher will, and she will take off. Okay, so when you don't have the angle, that's when you hit second sign, and it brings up this like inverse sign, and then you just type this bad boy in, and you should get your answer. If you're thinking, oh, I got like -1, what the heck? First I would say, stop talking like that, and then I would say, are you in degree mode? Hit the mode button, go to degrees, and then have a good day. All right, I'm not setting these up for you. They are so easy. I'm not even going to tell you what these mean because, you know, you have access to look that up. Okay, when you have slope-intercept form, that's y equals mx plus b. One of the main things you need to remember is that if they're parallel, they have the same slope. And if they're perpendicular, their slopes are opposite reciprocals, meaning you flip it. Like if it's a fraction, you flip it, and if it's a whole number, you just put it under 1, and you change sign, like positive to negative or negative to positive. So I'm just going to set up the first one of each one. If our line's parallel, that means the m is our slope. Remember that our slope's still going to be 5/2. However, on the one where it's perpendicular, you got to flip that to get 4/1 or just 4 and change the sign. So this one's positive, so our slope will be negative. And then to solve it, what you're going to do is use this for an x, use this for a y, and you're going to plug it all in here so that you can find your b, because this is not what you want to use for b. You have a different y-intercept. So you would do, here, let me rewrite this. Y equals mx plus b. So our y is 1. Our m is 5 over 2. Our x is 2. Then we have plus b. So you'd solve that for b, and when you write your final equation, it's going to be like y equals 5 over 2 x, and then plus or minus whatever you get for b. Now, it's real easy to eliminate 2 of these right away, which I would do on the actual test. But on the review, I would actually work it out, make sure I know what I'm doing, and then, freak out when I don't. And when you're setting up this one, you use your new slope, not the old slope. You don't use that at all. So when we're doing y equals mx plus b, we use the -4 for the slope. Our x is -1. And our y is +1. And then you solve for b. Okay, these are vertical angles. So vertical angles are always congruent. You should just be setting them equal to each other. These are segments intersecting in a circle, but not in the center, which is going to be part times part equals part times part. So when you do part times part, you're looking at the same line. So what are the two parts of that line? It's x and 20. Then what are the two parts of this line? 14 and 30, so we'll do 14 times 30. On inscribed quadrilaterals, opposite angles add to 180. A lot of people were setting them equal on the test, and that's it on the circles test. It's kind of confusing because on a parallelogram, the opposite ones are equal, but in an inscribed quadrilateral, they are not. They're supplementary. So I add them up and set them equal to 180. On this one, because this is, I can't highlight, because this is a diameter, let me highlight it and put a little arrow to it and then write diameter. Oh, good handwriting. That means that this is a, sorry, I'm trying to be cool. That's what I get for trying to be cool. Change colors. Good highlighting. That is a semicircle. Did I spell that right? Semicircle. Don't judge me. Nobody's perfect. Okay. God, I gotta erase it because I gotta print this out. This is my lie. Semicircle. Okay. And a semicircle is half the circle, which adds to 180, since the entire circle is 360. So 108 plus 4x plus 16 should equal 180. Ishy peashy. Okay, reflection across the y. I'm not going to do these for you. You just flip one point at a time. If it goes across the y, that means it's flipping over this one. And so they'll stay on the same line this way, but they'll go the same distance that way. And this one's the opposite because it is going over the x, so it will flip up to this quadrant. If anything's on the line like K, it doesn't move, it stays there. This is a translation, so it's asking you what happens to the points. Best way to do it, in my opinion, is to just figure out what a point is. Like B is -3, +1, and then figure out what it is over here. 1, 2, 3, 4, 5, -2. And see like how we get from -3 to 5, and that will tell you what you're adding to your x. Then do the same for y, and you'll see what's going on there. Okay, this is triangle sum theorem that we're using here. Also a throwback to the first semester, but should be really easy. all the angles in a triangle should add up to 180 degrees. Area of a triangle is 1/2 base times height, or base times height divided by 2. Here we're given the area, so you plug it in for area. 1/2, don't know base, height is 2.7. And you just solve that. These are a linear pair because they make a line, so you should be adding those together, and they should equal 180 since linear pairs are supplementary. All of these should add to 360, but then you also have, like, sometimes you have vertical angles or semicircles. Like these two should add to 180 because they make a semicircle, so you can subtract that from 180 to get this one. I'm not going to do that for you, mainly because I don't want to think and I don't have my calculator. But this one and this one are the same because they're vertical angles. And then these three should add to 180. So should be plenty easy to get that. And you're looking for EG. When you're given two letters, you go the shortest distance. So it's like from E to G. So you'll have to add EF and FG together. Okay, this is kind of confusing because it looks like the quadrilateral question, but it's asking for an arc, C, D, E. Now that is created by this angle right here, which is on the circle. And when an angle is on the circle, it is half of the arc. So you just have to take the angle and double it to get what the arc is. I'm going to write 110 times 2 so that when I come back to this question to answer it, it's really easy. Okay, these are parallelograms, so you can use your flip book on the exam, so that should be easy. Opposite sides are congruent, so you just set them equal and solve it. Opposite angles are congruent, but the same side interior angles are supplementary. So on this one, you'd add these together and set it equal to 180. Let's see, 180 times n minus 2, where n is number of sides. So all you have to do is count how many sides there are, plug that in here, you'll subtract 2 and multiply by 180, and that's what the sum will be. Okay, I gotta remember all these formulas off the top of my head. So let's see, surface area is pi RL plus pi r squared. I'm gonna just have to apologize if I mess up. I'm pretty sure that's right. The only difficult part about this one is knowing that that's the diameter, so you have to half it to get the radius is 10. But you're given this slant height. Maybe the difficult part would be knowing that L equals slant height, because if one more person tells me it means lateral, lateral is like a describing word, so I don't even know what that means. A lateral what? All right, and then surface area of a sphere is 4 pi r squared. Radius is 7. That one should be very easy, but see how pi is in your answer? So don't type that bad boy in that calculator. Okay, same with this one. Pi's in the answer, so don't type it in. But we're doing volume. Now, for volume of a cylinder, it says capital BH. But remember, capital B is area of the base. So the shape of the base here is a circle. Area of a circle is pi r squared. So really it's pi r squared h. H is always the distance between the bases. Same goes with this one. It's the same formula, but you have to be able to change this capital B. The shape of the base here is a pentagon. Now, if you look on your formula chart, it doesn't say pentagon anywhere because it says regular polygon because it applies to several different shapes. So regular polygon is 1/2 perimeter times apothem. Then you multiply the height. I like this one because I like to say half pa. This bad boy right here is the apothem, just in case you were wondering. Okay, center is pretty easy. It's going to be this number and this number, but the signs are supposed to be minus in the equation. So if it's minus, that actually means it's positive. I just think of it as the opposite. So if this is minus, you're looking for a positive 1. And that's the most I can say without just straight up saying the answer, even though I basically already did. And then the radius, if you remember, this equals r squared. This equals r squared. So you just have to take the square root of both sides. On this one, it's a nice pretty number. When you take the square root of 42, you might need to see if you can break it down, but based on the answer choices, I'm guessing you can't. You can use your flipbook, so this should be pretty easy. I'm not even going to bother. Okay, area of a sector. I'm just going to set up one of these. It's the measure of the arc. On your formula chart, it says m and then arc. I can't fit the whole measure of the arc in that tiny space, but a lot of people keep asking me who Mark is, and I just don't understand. But the measure of the arc is in degrees. So we're talking about the bold arc. That's 300 out of a total of 360. And that equals the area of the sector, so x, because we don't know that, over the area of the whole circle, which is pi r squared. I guess I didn't have to write the r. I could have put 18 squared. Again, pi is in your answer here, so you won't want to type that in. But don't forget that you can't leave a decimal in front of pi. So if you get a decimal, you're going to need to put math enter, and put back into a fraction. This will definitely have to do that, obviously, because none of them are whole numbers. And the pi is always on top. This is arc length, which is actually, I think, the formula on top of the two in your formula chart, so be careful about that. They're backwards, and usually I ask length of arc first, and I might have on the test, I don't know. Just pay attention to the directions. It says arc length or area of sector on your formula chart. So arc length, you do the first part the same, degrees out of 360. You're looking for this part, but on the bottom down here, it's not pi r squared, it's circumference, which is 2 pi times the radius, which is 4. Then you cross multiply and solve. Don't forget to put it back into a fraction if you get a decimal. On these, hopefully you remember, if you are doing a positive, you go this way, and negative goes this way. But I guess the most important part would be that you know you have to multiply that by 180 over pi to be able to decide how many degrees it is. You'll have to do that to both of them. But this one's positive, so, I thought that was my eraser. This one's positive, so I'm not going to do it for you, but you should be going this way. This one's negative, so you should be going this way. Also, let me just tell you what these numbers are, because a lot of people don't know them. First quadrant, second quadrant, third, and fourth. All right, this is all about matching up letters. So I really shouldn't have to help you that much. I would just make sure you look at like the number of congruent marks. The 3 will go with the 3. So they have to be in the same spot. So H in the middle, W should be in the middle. So we know it's not that one. Circumference is 2 pi r. Or you could also use pi times diameter if you're given the diameter. Some people prefer to half it and then plug it in here because that's what they're used to. Whatever you want to do is fine. These don't have pi in the answer, so you'll type it in the calculator. These are similar, which means their sides are proportional. So you're setting up a proportion. This one's a little bit tricky. Obviously, these two sides around the 65 are these two sides around the 65. But this one is, well, actually, no, I won't write that first. This one's obviously shorter than that one, but you have to look at this one and see if you think it just rotated or if it turned. And I think that this top part over here is the part that goes with this 39. It'll be pretty obvious on the test. So the 22 goes with the 33. and the x goes with the 39. And then you cross multiply and solve. If you set it up incorrectly and you get an answer that's not here, maybe try it another way. Because if the person I was helping in class did the 22 with the 39, which at first glance is what I thought it was too, but the answer wasn't there, so we just tried again. On this one, 8's obviously the shortest, and then 11. So then I look at this one and I think that this one's shorter. So 8 goes with the 24. That's x. Cross multiply and solve. I went ahead and drew these because it took me forever and it's still ugly and I didn't want you guys laughing at me because that would be rude. But these are probability. That's where you put like whatever you're talking about over the total. So the total is going to be like the shape that includes everything, which in this case is the square. So on bottom, we are going to put the area of our square. On top, it's whatever we're talking about. So this says the likelihood that it is inside the square, but not in the circle. So the parts that it's talking about are like these guys. And these are not shapes we know. People tell me they're triangles, but they're wrong. They argue with me, but, you know, I have a degree to point to, so it's not much of an argument. So since we don't have a formula for weird bent triangles, best way to do that is to just take the whole square, subtract the circle. That will give you that weird area. Then we always go to a percent by multiplying by 100. And I would keep my circle in pi form until the very end and just type it all in one big step. But you're either going to need to make sure you put parentheses around that or do the alpha y equals enter where it gives you the big fraction bar. Now it says what the radius is 8. So don't forget like circle is pi r squared. If halfway across is 8, all the way across is 16, which would make this 16 by 16. And for the square, I would just do base times height, or length times width. It's going to be 16 times 16. But this one, when it gives you this, it's no longer half the side of the square, it's half the diagonal of the square. So this is just the shapes flipped. So now we've got our circle on bottom, and it's still talking about these weird shapes on the outside. Like I feel like I want to be lazy, but then I think about printing this and how ugly it would look if I didn't finish coloring it in. Okay, so that's the shape we're talking about, which the only way to get that is to take circle and subtract square. Always multiply by 100 to get it to a percent. Now we have the radius is 6, so you still do pi r squared for this. But for the square, there's lots of things you can do for a square. The easiest on this square, since you have half the diagonal, is to write that the whole diagonal is 12. This diagonal would also be 12 because the diagonals are the same on a square. And I would do 1/2 diagonal 1 times diagonal 2. That's basically it. I'm not going to set these up for you because that would be insane. That's all in your flip book, and you can use your flip book. I know it's hard to read those. Like I even have to read them like 4 or 5 times. Sometimes 7 to 8 to 9. And once I had to read one 12 times. But that's because someone was talking to me. Just, see what you can do. There's only 2 questions about this on the final, and I feel like one of them's pretty easy. One of them's kind of like these first few that are kind of confusing. Maybe not this one. That one's pretty easy. Okay, so good luck. Oh, and good luck to me too, because I don't know how to get out of here.